Hi everyone, I am Vanshinathan, Assistant Professor in the Department of Physics, K.S.Rangasamy College of Technology, Tiruchengodu. Today, I will be discussing Module 2 of Engineering Physics, Optics and Laser Technology. In this session, we will particularly focus on laser, its definition, properties, working principles, and theoretical concepts. Outline of our model 2, introduction uh, of laser. Then we will discuss its unique properties which make it different form of ordinary light. After that, I will explain the concept of laser action and how it works. We will also go through Einstein's quantum theory of radiation, which gives the theoretical foundation of laser operation. What is laser? A laser is an optical device. The word laser itself stands for light amplification by stimulated emission of radiation. Lasers are widely used in areas like medical surgery, communication, industry, defense, and even in everyday device such as barcode scanner and laser printers. The properties of laser. The first property is coherence, and then second property high intensity and high directionality and high monochromicity. Coherence, it means all the light waves in a laser beams are in same phase and same wavelength. And ordinary light waves are random, but it's deviate in the different form. And then a second one, high intensity. The high intensity compared to ordinary light, for example, 1 milliwatt laser is an 1,000 times powerful than an ordinary light or 100 watts ordinary light. This is the high intensity compared to ordinary light and laser light. And then a third one is directionality. Laser beams do not spread much as they travel, meaning they can cover long distance with significant loss. And then finally, monochromicity. It means laser light consists of almost a single wavelength or it's a single color. These are properties of laser. And then comparison of ordinary light and laser light. Ordinary light is spread in all direction, but laser light it will concentrate on a particular point. The ordinary light is not an directional, but laser light is an highly directional. And then ordinary light, less intense beam. And then laser light is an highly intense beam. And then final one is the example of ordinary light, sunlight, mercury vapor lamp, and sodium vapor lamp. And but laser light is an example: helium neon laser, NDR laser, and CO2 laser. As a result, it is less intense and cannot be focused on long distance. And then laser action. Now let us, how can lasers or works? The basic principle behind a laser is an condition is called population inversion. So population inversion is nothing but more number of atom present in the excited states compared to the ground state is called population inversion. In normal population, so more number of atom present in the ground state. This chain reaction results in highly coherent and intense beam of light, which we have a laser beam. Therefore, without population inversion, laser action is not possible. Then Einstein theory of radiation. The Einstein theory focus on the following three process. The first one is absorption, the second one is spontaneous emission, and third one is stimulated emission. The first absorption is nothing but this process The atom in the ground state can absorb the photon of energy. It will goes to the excited state. This process is called stimulated absorption or absorption. And then second one is spontaneous emission. Spontaneous emission is nothing but the atom in the excited state returns to the ground state without any help of external radiation. This process is called stimulated emission. And then finally, stimulated emission. So, stimulated emission is nothing but the atom in the excited state returns to the ground state with the help of external radiation is called stimulated emission. These three process is explained in the Einstein in the year of 1917. The first absorption equation is developed in Einstein. The mathematical expression, the following three process. In ordinary condition, spontaneous emission is more common, which leads to incoherent and weak light. The absorption is the stimulator absorption. So R12 equal to B12 rho into N1 is the stimulator absorption or absorption equation. And then spontaneous emission equation. So R21 equal to A21 N2 is the spontaneous emission equation. And simulated emission equation is R21 equal to B21 rho N2. These comparison at under equilibrium conditions, the rate of absorption equal to the sum of rate of emission. So the absorption of rate is B12 rho N1 and the sum of rate of emission is A21 N2 plus B21 rho into N1. The left side of rho value is simplified B12 N1 minus B2 N1 equal to A2 N1. So the calculation of rho is A21 divided by B12. So N1 by N2 minus B21. We know that the Boltzmann distribution law. So N equal to N naught exponential minus E1 by kBt. Further simplification, N1 by N2 equal to exponential E2 minus E1 divided by kBt. The further simplification using Planck's radiation law, rho value is 8 by h nu cube divided by c cube into 1 divided by exponential h nu by kBt minus 1. So therefore, the finally you got the intensity of radiation of Q equal to B12 equal to B21 and A21 divided by B21 equal to 8 pi h nu cube divided by c cube. This is the conclusion of our Einstein AB coefficient. Stimulated emission rate is same for spontaneous emission, but the stimulated emission is predominant for laser action. Uh, Today, conclude our session. We have seen what a laser is, how it is differ from ordinary light, and why it is unique. We discuss in the properties of laser: coherence, intensity, directionality, and monochromicity. So we have understood the laser actions and importance of population inversion and Einstein quantum theory of radiation. So lasers are not just a scientific property. They have enormous application in medicine, industry, defense, and communication. So thank you all.